understand the impact of Brayton Point on human health and the environment for coal and natural gas cases, we decided to look at 4 different types of pollutants. For 3 of these, we estimated the impacts using available studies, and for one of these, the criteria air pollutants, we used actual model runs. So for the criteria air pollutants, we used the AMS EPA regulatory model. In 2009, Dominion Energy submitted a prevention of significant deterioration application for its cooling tower and dry scrubber projects, and used these as inputs into the model. We used these model outputs and translated them to health impacts using a 2000 study conducted by Jonathan Levy at the Harvard School of Public Health. Furthermore, SOx and NOx emissions were estimated using a 2000 report from the National Renewable Energies Laboratory. For toxic chemicals, we estimated the impacts using EPA's toxic release inventories for burning of coal and natural gas. And to look at thermal pollution effects, we also looked at a 1999 EPA case study of Brayton Point. Finally, for greenhouse gas emissions, we used EPA emissions factors for natural gas and coal combustion, and to estimate life cycle emissions, we used emissions factors from the same 2000 enrollment.
So finally, to model the impacts of replacing Brayton Point on energy prices in Massachusetts, we used historic market price data and energy data to sort of create supply and demand curves. And so the curve you see up here for supply is sort of an average yearly price of electricity, so it relates how much does electricity cost at different levels of demand on the system. And then the demand curve here is showing how demand distributes across over the year. And so by combining these 2 curves, we created an estimate of how much does it cost every year to generate electricity in Massachusetts. And so to simulate removing plants and adding plants, we basically make shifts in the supply curve. Then to model changes in energy efficiency, we would increase or decrease the demand curve. And so to dive right into our results for the grid, this is sort of a summary of our different scenarios, looking at different energy efficiency results and different replacement scenarios. And as you can see, our findings at least show that the impact on overall cost going to natural gas was actually relatively small. One big variance factor was that as the price of natural gas changes, it has a really big impact. And in fact, if the price is above $7 per MMBTU, and right now it's about 5, we found that it wasn't actually cost effective to ever build the plant. And so you sort of see not a lot of effects, and then once you hit some threshold value, it peaks and it's just not cost effective to build your natural gas plant anymore. And then second, you see that as we increase the amount of energy efficiency in the state, it actually drops the prices in electricity. And the reason for this is because we're avoiding generation at these really peak times of the year, right in the summer when it's really warm, when it's very expensive to generate electricity. And so by reducing overall demand, we reduce the overall costs, and therefore the average prices.
Now for a discussion of the air quality and human health impacts. The bottom 3 plots illustrate the results of our AirMod runs. And as you can see, the business as usual case results in the highest concentrations of pollutants around the plant. The average of that is 0.2 micrograms per meter cubed. Now going to the natural gas retrofit and replacement cases, that decreases by a factor of 4. Now this is important because these concentrations are high near high population areas such as the city of Fall River and the surrounding residential areas. So decreasing the concentration will result in significant health effect improvements. As illustrated in the table above, under the business as usual case, there's estimated 19 premature deaths. Going to a retrofit case will cause an 84% reduction in the health outcomes. And going to a replacement case will further reduce the health outcomes. So 3 premature deaths for retrofit, 2 premature deaths for replacement. And for greenhouse gases,